Hi there. Okay, so I want to make this a separate video, and we're just going to look at the different families on the periodic table, and we're going to color in our periodic table as well at the same time. So I'm going to get 5 different colors. So I have 1, 2, 3, 4, and 5. I don't want to have anything too dark. And we're just going to outline to begin with, okay? So I'm going to start with my alkali metals. So the alkali metals, right, are this very first column here, okay? So our alkali metals are most reactive metals on the periodic table. Okay, and why is this? Because they only have one valence electron. So every atom on the periodic table is trying to become stable. It's trying to become like whatever noble gas it's closest to. So fluorine and oxygen and nitrogen, they're all trying to become like neon by gaining electrons and becoming stable. Whereas beryllium and lithium, they're trying to get rid of electrons to become stable like helium. Okay, so because they only have one, it takes no effort for them to get rid of that one, and so it makes reactions really volatile. Okay, so they are never found free in nature, thank goodness. Okay, they have to lose an electron. To be stable, okay? Atoms are very lazy. They want to do the least amount of work as possible to become stable. And for them, alkali metals, it's much easier for them to lose the one valence electron than to try and gain 8 or 17 or 7 or 17. That's just a lot more work, okay? And they are most likely to bond with halogens. Okay, and why? Because they are just missing one electron. So they have one to give and halogens are missing one. So that's why they want to hook up all the time. Okay, and alkali metals also produce basic solutions. And that'll come in handy when we do our acids and bases in a little bit. Okay, so let's start with, take a pencil crayon, and I'm just going to outline the alkali metals, but don't include hydrogen. Okay, hydrogen is in a family of its own, so I'm just going to outline everything in that first column. And if you use a pencil crayon, then you won't smudge out the atomic masses. Okay, there we go. Okay, and I'm going to make a little table here, a little key. Okay, so at the top, okay, make a square, and this is my alkali metals. Okay, right up. Okay, next up is going to be the alkaline earth metals, and that's the next column. Okay. My pen, here we go. So alkaline earth metals, here I'll make this a little bit bigger, okay, they're also very reactive. But a bit less than group 1. Okay, they have to lose, so they must lose how many valence electrons? 2. They must lose 2 valence electrons to be stable. Whoa, sorry. I guess you can't really tell me, Miss Labiuk. I can't see. Okay. They are Stable. Okay, must lose. Okay, what else? Okay, they react with water to make basic solutions. Okay, so not acidic, the opposite of acidic solutions. Okay, and well, that's about it. Okay, right on. So far, so good. Okay, so now let's go to our periodic table. So here are our alkaline metals. Sorry, it's blurry. Okay, and remember they have 2 valence electrons, 1, 2. Everything in this column has 2 valence electrons. So let's take a different color and let's outline that family. Okay, and pencil crayons, maybe you have like some crayons from your brother and sister kicking around. Okay, and I'm going to add that to my little legend here. So the orange is alkaline earth metals. Okay, not alkali earth metals, alkaline earth metals. Okay. Right on. I'm just going to double check something here, but that's totally okay. Okay, next up is chalcogen. So those are the 2 metals, the families of metals that we care about. Now we're going to come to the other side here. Okay. So chalcogens, they need 2 electrons to be stable. Okay, and they make anions, okay, or negative ions. Okay, and you're like, oh, what does that mean? We'll talk about ions in a little bit. Okay, so I'm going to come back here. I'm going to take another color, and I'm going to outline my chalcogens, and these are the chalcogens. We're going to start with oxygen, across and down, all the way down. Okay, luckily these pencil crayons are very faint. Okay, so those are all chalcogens. Okay? And it has like a silent H, okay? Chalcogens. I know when you see the word, you always want to go chalcogens. I know, it's so weird. Okay, chalcogens, okay? And the next one after chalcogens is halogens. Okay, so I'm going to get another color here. Let's see. Green, and I'll just outline it first, and then I'll go to the notes, okay? So I'm going to outline my halogens. Okay, so we're not coloring anything in, right? We're just outlining, okay? So make a little box here, and those are my halogens, H-A-L-O-G-E-N-S, okay? Okay, so what do we need to know about halogens? Well, you probably can guess it, okay? Halogens need 1 electron to be stable. Okay, they also form anions. Okay, and halogens are the most reactive nonmetals. Okay, and what else? Oh, they also have, most of them are all diatomic molecules. Okay, and I'll talk to you a little bit more about that, what diatomic means or why that's important, but we'll come back to that. But halogens are diatomic, okay? And our last one, our last family that we know or that are important for us is our noble gases. And why? Because they are the most non-reactive elements. Okay, sometimes they're called inert, which is another word for like non-reactive. Okay, so they don't gain or lose electrons, and because they have full outer shells. Okay, right on. So let me find a color for, oh, I did blue. Let's see, noble gases. So we have orange, green, blue, yellow, red. Okay, so my noble gases here are the very last column. So I'm going to outline here. My coloring skills could use some work. Okay, if you want to just use different colors of highlighters, whatever, it's totally up to you, okay? But this is our last family here, so I'm going to add this here, and this is our halogens. Oh no, sorry, this is our noble gases. Awesome. Okay, great job. And those are the different families that we need to know about. And we will kind of elaborate and keep on talking about this as we go. Awesome. Thanks.